Okay, so there are the two formulas that I had talked about. So again, both of them are completely valid, and you can make your decision as to which one you want. I would truly recommend that when you have an opportunity to use the formula, that you stick with the second one, though. It's just a recommendation. University, college, you're gonna end up using that form, and you can also title this, save us a little bit of time a little bit later on. This is the fundamental theorem of calculus. So as we move through, I'm going to start calling it our fundamental theorem of calculus, that expression right there. All right. So a couple of examples. Find the slope of the tangent line to that curve at x equals 2. So I'm going to go with the equation m equals the limit as h approaches 0 for f of x plus h minus f of x divided by h. So limit h approaches 0. So that function, everywhere there's an x, I need to replace it with an x plus h. So I'm going to end up with it looking like this. I will have x plus h minus 3 squared minus x minus 3 squared over h. So that x that was there, this x right here, I had to replace it with x plus h. So it makes it a little bit challenging when you go to do the expansion. And when I do the expansion, you can write it out again, or you can skip steps. It doesn't matter to me. But it's being multiplied by itself. So I'm going to end up with x squared plus xh. So I'm just doing the expansion, just so you know what I'm doing. I'm doing it in my head. Okay, I'm doing this expansion, so you'd have to write it twice and then use distributive law. So I know the x is going to multiply each term in there. So I know it's going to multiply itself, x squared, multiply the x, so you get xh minus 3x. Now the h is going to multiply each term. So I'd get an xh term plus h squared minus 3h. And then the negative 3 is going to multiply everything. So negative 3x minus 3h plus 9. Minus, and now I have to do the expansion of x minus 3 squared. I'm going to have to use a bracket for this. X squared minus 6x plus 9. So you can see being quick with distributive law is a benefit here. Now I can start doing some simplification though, and what we'll find is a lot of stuff will drop out for us. So for example, this x squared and this x squared will cancel out because that negative has to be distributed in. The negative, what do I have here? I have negative 3x, so it's negative 6x, and it will cancel out with that one because it's going to be positive 6x. So those guys are gone. And then the constant, I have a plus 9 here, and I'll have a minus 9 in there. So that will clean up. Now you can write it out again and collect like terms. It doesn't really matter. What am I left with? Well, I have 2xh's, so 2xh, and so those guys are now gone. I have an h squared, so plus h squared, and then I have minus 3h, so minus 6h over h. On top, we still have a problem. On top, every term has an h. 2x plus h minus 6 divided by h. And you know what? It's a self-check. This works every time. There is no time where this does not work. So every time h will factor out when you get to this step. If an h does not factor out, then you've done something wrong. You've got a little mistake. So anyway, because everything canceled out, I know I did it properly. I'm left with 2x plus h minus 6. Do I have a problem? Absolutely not, because there's no denominator. I substitute the h in, and I get 2x minus 6. So just going over here. So therefore, slope is equal to 2x minus 6. And this is an expression for all slopes on this curve. So now I just have to plug in, if I have 7 points to find the slope for, I just have to plug in the x value each time to get that slope. So this question wanted us to find the slope of the tangent when x equals 2. So therefore, when x equals 2, the slope will be 2 times 2 minus 6 will be negative 2. So therefore, slope of tangent is negative 2. There we go. So you can see where if you had multiple slopes to find, it would be much better with this second process. Okay, final example. What happens if it is a rational function? Okay, the process still works for rational functions. So equation of the curve at x equals 2. We're still going to find slope. So this time we want the equation of the tangent, but we still need slope. So the limit as x approaches h for f of x plus h minus f of x over h. So the limit as x approaches h. Now that function, the fraction is going to be x plus h on top over 2 minus 3 x plus h minus x over 2 minus 3x. That's all over h. So there's going to be some people in here that are starting to panic a little bit, but what you'll find is this does clean up a little bit. It does take some space though. So I got to clean up that first denominator. So I have x plus h over 2 minus 3x minus 3h minus x over 2 minus 3x all over h. Need to get a common denominator. What we do is we try not to make this too hard on ourselves. Common denominator will be the 2 minus 3x minus 3h multiplied by 2 minus 3x. So on top, that x plus h term will have to be multiplied by 2 minus 3x. And the x term is going to be multiplied by the 2 minus 3x minus 3h term. Now we need to clean this numerator up for ourselves. So we end up, there's going to be some distribution, lots of things will cancel, etc., etc. So doing distributive law, I end up with 2x minus 3x squared plus 2h minus 3xh. So that's the first set of brackets. I'm going to distribute in a negative x. So I have negative 2x plus 3x squared plus 3xh. That's all over that denominator. Never, ever, ever expand out the denominator. Never, ever. Okay, numerator only. And that's all divided by h. So what cleans up here for us? So obviously there's not going to be 6 or 7 of these on the test. Hopefully you realize that. 3x squareds, they're canceling out. My 2x's cancel out. And my 3xh's cancel out. So all that's left is 2h on top. So I'm going to save myself one step here. It's a fraction divided by a fraction. So I'm going to have 2h over this massive mess, bracket, bracket, 2 minus 3x. And the denominator, we would flip it instead of dividing. And what happens then is now this h and that h will cancel out. And hopefully someone said, what are you doing underneath here? I did it all the way from the start. This should be h approaching 0, my limit. Probably some of you thought he'll figure that out eventually. I apologize greatly. At least I remember the notation, even though it's incorrect. H approaching 0, h approaching 0, and x approaching h. I don't know what I was thinking. Thinking it's time to quit. That's what I'm thinking. Okay, so do I have a problem anymore? Okay, so now I'm back to this original expression. I'll write it out one more time just to clean it up. You don't really have to do this again. But the question is, do I have a problem in the denominator? Will it equal 0 if I put h as 0? So if h goes to 0, this disappears, and we end up with 2 minus 3x. So the limit as h approaches 0 is 2 over 2 minus 3x squared. All right, so therefore, the slope of any tangent line is defined by that expression there. All right, now we want to find the equation of the tangent line at x equals 2. So just finishing this up, at x equals 2, our slope will be 2 over 2 minus 3 times 2 squared. So on the bottom, 2 take away 6 is negative 4, squared is 16. So our slope is 1/8. And the y-intercept, we'll have to plug in that x value into the original equation. So we're not quite done. So the original equation, f of x equals, actually let's just substitute it in right now, f of 2 equals, the original function was x over 2 minus 3x, so 2 over 3 minus 2 times 2, oops, was it, I can't remember, 2 minus 3x, 2, get this right, 2 minus 3 times 2, so 2 over negative 4, or negative 1/2. So now we have our point. So now I'm going to use the point slope method that we learned in grade 9. So y equals m x minus x1 plus y1. So my value would be, the slope is 1/8, x minus 2, and the value is minus 1/2. So there's the equation of the slope line, and you can distribute it in, but I'm not too worried by that point in time. So there is your final equation. So yes, there is a little bit of algebra involved, but remember, I'm a process marker, so if you make small mistakes, don't get flustered. There's the assigned homework for this section. If you do have problems, let me know, and we'll take a look through. Rational expressions are definitely the more challenging, and you are going to need some paper space here, so make sure you have lots of paper stocked up.